Welcome to qnawire.
This problem is about what happens when the coefficient of friction decreases as you are navigating a curve in the road. So the information that we're given is the initial velocity that we're traveling at. We label that VI more specifically, as well as the fact that the driver crosses a puddle and our coefficient of friction between the tires and the road decreases to 1/3 of its original value. Now I've drawn a three-body diagram here on the left showing the normal force canceling out the gravitational force, as it always does in these problems, and the frictional force pointing inward. So the frictional force must be responsible for force of F, friction, which is going to be responsible for our centripetal force. So FF must equal mv squared over r. Now the force of friction is always equal to our coefficient of friction multiplied by our normal force. And as we can see from the free body diagram, our normal force is just equal to the gravitational force. So it must be equal to mg. So from here, we can go on to write an equation for our initial velocity. And that just means rearranging everything. So v squared equals, or vi squared equals r times our initial coefficient of friction times g. So vi is just equal to the square root of that. And that means that our final velocity must be equal to r times theta I over 3g. Now, let's compare these two values. R and G are constants. So if we set up a ratio of these two, VF over VI, we find that is just equal to square root of the coefficient of static friction over the coefficient of static friction divided by 3, also square rooted. Our coefficients of friction are going to cancel out because they are also constant, and we find that rearranging VF is just equal to the square root of 1/3 VI. So since we're given our initial velocity, now we can just plug in to solve. I'll rewrite here a little bit more clearly. VF is 1/3 of square root of 1/3 times V initial. So we get that that's root of 1 over 3. Oh, my bad. 1/3 times 21 meters per second, which we're given as our initial velocity, and that is going to be equal to 12.124 meters per second. And that is going to be the maximum velocity that the car can navigate the turn after the decrease in